guys. Welcome to our August all-staff, Immunology all-staff meeting. Looks like some folks are still getting pizza. It's interesting, the lighting here. It's like I can't, with the bright light behind, I can't actually see anybody's faces. But everyone's eating happily, that's awesome. Cool, all right, well, let's go ahead and get started. We have some operational updates today, and then, so that's kind of our same format that we've been using for a while. So we'll go through some updates, and then our big ticket items today, we have Paul, who's going to be giving a presentation and talking to us about open science. And we actually have Andy Hickel here with us today. This also kind of follows along with the our recent theme. We had Chris at our last all-staff meeting, and we have Andy here today. So I think Ernie is going to introduce Andy, but Paul's going to introduce Andy. Okay, somebody needs to introduce Andy. Okay, and then we'll move into questions and suggestions and feedback. And part of this will, and I think this was a message, part of this, we have our office hours right after this, and so this will kind of move right into that and give an opportunity for discussion and questions on a number of things. All right, so first of all, let's do this. Let's welcome some new team members, and I'll just mention too that, and I think this is later in there, there's an opportunity later in October for a new Allenite photo. So that, I think it's on everybody's calendars. I think that they sent that out to everybody at the Institute. So that's coming up for a new, we can get a new picture there eventually. But we have a couple new team members. We have Austin Wang, back-end software engineer. We're reporting to Nicole. Is Austin here? Working from home, okay. Welcome, Austin. And we have Juhi Sun, who is a scientist in the inflammation group, reporting to Adam. Is Juhi here? Yay, Juhi, welcome. Welcome to the Institute. We're happy that you're here. And now it is with new lab members. We also have a few folks that are leaving us, and both Nelson and Jasmine departed late, I guess. Yeah, Nelson was the end of July, and Jasmine just earlier this month. So we're sad to see those folks go. They were here with us for a while in our postbac program, and significant contributions to the work that we were doing at the Institute. Okay, so we have a number of anniversaries. We have, a lot of one-year anniversaries. Thanks for hanging in there. Ali, so these are all folks, looks like, started in July and then in August because of our 2-month rotation. So we have Ali and Anna, Max, Den, Han, Kelsey, and Ashwarya G, who all have been with us now for 1 year. So thanks for hanging in, and congratulations on your 1 year. 2 years, we have Aaron, who's been here 2 years now, and so thanks to Aaron, and appreciate all the work you're doing. 3rd year anniversary, Tiana and Peter. You guys here too? Is everybody, those guys, I think I saw you all come in, didn't I? Yep, hey Peter, Tiana's here somewhere. Good job, you guys, thanks for hanging in. 4th year anniversaries, we have Claire and Nina. And Nina has 4 years in immunology, right? Yeah, okay, so with a couple of extra years or something added on from brain, right, I think? Yeah. 6-year anniversary, Nicole is celebrating 6 years with us in the immunology group. This is getting back to now early days in immunology. Nicole, is Nicole here? Aw, that's nice. Yeah, that's great. She's on holiday. And then Lucas is actually, I think, on vacation too. And Lucas is 11 years overall at the Institute. Lucas started in brain science back in 2014 and moved over to immunology then 5 years ago now, I think. Lucas has been with us for a while now, I think. All right. What's that? Yeah. All right, so happy work anniversary, everyone. Thank you for all you do for immunology, and we're very appreciative. We are hiring. We continue to hire. This is just a snapshot. We currently have 107 folks on the team, and we have 6 positions posted, 1 new hire, 1 position is just newly hired. But these are the open active positions, so if you know of folks that fit those positions and you think would be good fits for the Institute, let us know. There is that referral bonus. So if you do have somebody in mind, let them know. Let us know. And then we just made an offer, I think, as a newly hired bioinformatics scientist that will be joining us as well. So keep that in mind. We continue to grow just a little bit. We're as we are like 107. That's pretty cool. Conferences, I'll just mention this, and this is not comprehensive. This is just, we pulled, some conferences out. There could be others that you're attending, but these are some upcoming ones that we may be attending or we know folks are attending. And I'll just mention too that, I'm just gonna exit this out here quick. I just want to, just a reminder that, and I think Dakota's going to put this in the chat, just a reminder that there's that conference form that we'd love for y'all to fill out that gives us an idea on, what your plans are, what conference you're attending, if you're presenting, what your presentation title is, and that sort of thing. It helps us, understand the impact that you all are having as you go out there and message the cool work that we're doing. So I think Dakota's going to put that in the chat, and so it'd be great if y'all could fill that out. And then we have a number of invited speakers coming up through the rest of September and Q4. And again, I think this is everybody, but there might be somebody else coming on that list at some point. But keep an eye out for that. Those should all be on your invite, on your calendar. All right, and just I think one last thing is just a reminder, the summer party is coming up on September 9th. Again, this should all be on your calendars too. If you haven't had a chance, please RSVP to that. We're going to Citizen Campfire, which is just down in Lower Queen Anne and easy walking distance. They have a nice outdoor space. It's from 2 to 5 on Tuesday the 9th. There's appetizers, drinks, there's games. Please let there be a photo booth. We'll see, but I'm really hoping for that. So that'll be super fun. So we want to just enjoy and celebrate a number of things and milestones and deliverables that y'all have hit this year. So that's just a big celebration for immunology. Some other important dates coming up. You can take a look at this. We have the showcase coming up on the 4th. This is an all Allanite event. We will have some posters there as well. And so keep an eye out for that. Summer party, we're budgeting. There's an all Allanite meeting coming up in the end of September as well. You get a picture taken in October, and then that leads us up into the holidays there. So things to keep a lookout for. A couple of shout outs. The RA conversion Ultra manuscript is formally final been accepted in Science Translational Medicine. So good job, autoimmunity group there. Yeah, hanging in there and doing all that work to get that across the finish line was no easy feat. So good job. And then the long COVID research article, I think Samir posted this recently in the lunchroom chat, but that was also published in the Journal of General Internal Medicine. That was a collaboration with the Washington Latino Center for Health at the University of Washington. Yeah. All right, and then that brings us to Paul's presentation. I think I'm supposed to unplug this, right? I'm going to do that.
Yeah, everybody was so organized to put the slides in one spot, except for me. So I'm going to get it from my computer.
Thank you.
Yeah, of course. Get confused which one to use. All right. So, hi everybody. Hey Lynn, talking about conferences, I'm going to be presenting at a conference. September 13th and 14th at the Open Science Fair in Geneva. And so this is actually a draft of the presentation I'm putting together. So the Open Science Fair is not, as you might imagine, a health and life sciences conference. It's really for people that are doing science and open science, which is its own discipline. So the people come from all kinds of scientific disciplines: social sciences, life and health sciences, quote unquote the hard sciences, and as well as lots of policy people to worry about, and think about how do you promote open science as a discipline and how do you make it effective. And so I'll be doing a short, 4 iterations of a short presentation there. And so some of the slides you'll recognize, and some of the slides are new because, of course, this is not an audience that is from our scientific domain. But hopefully you'll enjoy this. Some of this is a little different from how you've seen it before. And I've got all kinds of facts in here. So large-scale research presents transparency and reproducibility challenges. You have to deal with large amounts of data. Then you have to prepare that data for transformation and analysis. You have many steps of analysis that you need to keep track of. Large-scale research is interdisciplinary research that we're all very familiar with. So how do you support that? How do you make sure that as the research is going, you have transparency how it goes? And then when you're ready to publish, how do you share that? And how do you ensure analysis reproducibilities? And finally, that's something that traditionally we've talked about less. How do you keep research available, affordable, and sustainable? So here's a use case. Well, this is, of course, the stuff you're intimately familiar with, but here's a use case of what large-scale human immunology, of what large-scale research is, and in our case, human immunology. I think I do not have to say anything about this slide because you've seen it many times. But of course, what we're dealing with is really complex, right? We have longitudinal studies with multiple assays from the wet bench. We generate lots of data in the process, both many different types of assay data on a single time point, and then typically many different time points with many different cohorts. And then we have a computing platform that needs to keep track of that all. So yes, what it does, what is large-scale research does, it generates lots of research assets. And there are so many steps. As you can see, isn't this complex? And it gets more and more complex. Boy. That's all the stuff you do every day. And so, how do you deal with managing transparency and reproducibility for large-scale research? And so what we've been building together is a comprehensive platform built for reproducibility and openness. So how do you deal with complex multi-step analysis? You capture research as it unfolds. How do you do transparent ongoing review? You enable the re-execution of steps. Team collaboration, you trace all tools and transformations so everybody can always see what's going on, even if they weren't the ones executing it. Then you share data, analysis, and results directly from the computing platform itself, right? So that's somewhat a different notion because, you have Sonodos and other platforms that are just specialized in or the open science framework that are really specialized in just the transparency aspect. But what we're saying is we've built one platform where you can do all the research and then share out the research. Analysis reproducibility, you're very familiar with that. So you share not just the results, but the entire research trace with it, aka SERPRO. And then finally, available, affordable, sustainable. You are then using the data that is out there in the open science community to understand what is being used and what is not being used. And on the basis of that, you make data governance decisions. So, for this audience, I then introduce what HEIS is. I'm going to skip right by that because, of course, this is what you do every day. But the critical part there is it's not just a computing platform to do the scientific computing, but it's also the platform to do the open science dissemination and interaction. And again, that is uncommon, I would say. So how does this all work? Again, something you're super familiar with. But of course, we have trace-driven architecture to track all the data and transformation in a proactive manner, right? So it's a platform designed for traceability. We register the data and the transformation as it happens. And so we incrementally build out a graph of all the exact steps you did to undertake the research. And then when this comes time to publishing or releasing the data, we publish all of that, not just the data, the code, the tools, and the steps to get from data to tools to the next step, the next data set. So how does that really work? So in the wet lab, we have data that is generated and ingested, as well as lab metadata details. And we also have clinical metadata collection that goes into the system. Then we have automated pipelines that do some of the heavy lifting on large amounts of data. And we have automated analysis and verification. We do that secondary analysis, also all the stuff that we do in the IDE in many, many different steps to do cross-sample, cross-cohort, or multiple time points in the same person comparisons where we have multiple steps of derivation, and then in the end we generate the results that will show whatever we are trying to show here. And ongoing, as we doing the research, anybody can go in and say, what do we do here, right? So go to the collaboration space and review everything that had happened that was relevant to a particular hypothesis you were trying to explore, or the discovery that you were doing. And once it's published, different people in the open science community can actually essentially do that same step, but then in a verification manner, right? So you can rerun pipelines, you can download data, you can verify analysis, and again, you can interpret results. And as you think of our data apps, it has all those components, right? So where we really try to reach lots of different people that are just interested in the data to do their own analysis, people that really want to look through the data app and try to interpret what you're saying, people that don't know how to code but can use the interactive visualizations to play with the data. We really try to deliver something that just like we want to make sure that everybody in the interdisciplinary team effort has an opportunity to understand what we're doing. In the open science community, we want to have that same interdisciplinary reach. And of course, what I showed was a highly stylized picture, and you've seen this before. So this is, the Human Immune Cell Atlas, where we have lots of pipeline runs, many analysis steps, many different output files, and results from many different samples. So kind of going to the review steps. So far we have talked about the first bullets, which really talks about sort of the analysis reproducibility principles, or as we call it internally, the CERT-Pro principles of what we do. So now we kind of go to the second part, dealing with governance. Again, the question was, how do you keep stuff available, affordable, and sustainable? And so ongoing usage guides governance. So what does that really mean? Well, it means the following. At first, when you look at the data side, you want to keep data available that is used for new studies or by the open science community. But you want to archive all the other stuff. Abandoned analysis paths, data has lost interest. And also you want to look at sustainability. Does it always make sense to keep the data around, or you want to just regenerate the data if necessary, when necessary with modern methods? So on the tool sides, it's similar. So keep the tools and algorithms so they can continue to run, But again, only do that for the ones that are actually being used. So over time, if you find that, you know, certain things are no longer of interest for whatever reason, discontinue that, because of course, keeping tools out there brings with it a sustainability burden. So, and then the things that are still relevant are still being used, keep in mind that you need to manage and upgrade these tools so that they continue to run, because software is, you know, finicky, and over time, you really need to make sure that everything keeps running. So what does that mean? Well, here is a schematic of all the research traces that are on HEIS, and the green and the blue ones are really the two that ended up getting published. And so, in other words, not all the research traces that we have in HEIS actually end up getting published, right? So you have, for whatever reason, incomplete data, quality issues, mistakes were made, the tool failed to run, you know, was a dead-end path. And so everything that wasn't used, you can archive, right? Archive the data, discontinue the tool. Keep the stuff that is relevant and archive the stuff you no longer want. And even for released data, and this is, again, this is not actually any of our real releases, you might find over time that some of these releases just, you know, are no longer of interest. And so at that point, you have to make the same determination, right? Does it make sense to keep it around? Does it make sense to keep the data there and to keep upgrading the tools, which can be very costly over time? Or do you say at this point, maybe we, you know, maybe we'll archive this? So in other words, these research traces inform sophisticated data and tool governance policies. So, and it really affects collection, it affects storage, and then it affects the utility of it, right? So what we're really talking in the last slide was about the utility aspects of it. And so using this research trace, it's a much better way, I believe, to understand what is relevant in data and tools, right? So if you look at sort of classic IT metrics, they say, oh, this data is 10 years old, maybe we should archive it, right? And, or this data is very large and costly, maybe we should archive it. And so if you actually use the use by the open science community to drive, this stuff is relevant. It doesn't matter if it's 1 year old or it's 15 years old, like, you know, Brain Science has the mouse brain atlas, which is still one of the most popular tools today. It's been out for 15 plus years. Like, if you really look at how people are using it, then you can do a much better job understanding what do I need to keep around, what do I need to maintain, and what can I get rid of. And so what you end up is a balance. Here's my holistic view of sustainable research. So, because this is really what we're trying to do, right? We want to enable original research, and we want to support open science. And in order to do both, you need a sustainable approach to science, right? You need to balance financial health, infrastructure, and the expertise vital both to launch new research and promote open science engagement. And this is the other paper that we released last month, something like that. So in summary, transparent interdisciplinary analysis drives reproducible and sustainable research. In other words, large-scale, compute-intense interdisciplinary research requires proactive traceability of analysis as it unfolds. Releasing data with its research trace ensures reproducibility, and usage patterns of trace data and tools inform retention governance. So you get this perfect cyclical nature of how we do research. And that is it. Questions? Any questions? Ed?
Question.
Yes.
About the delete data. Who determines whether data gets deleted and when it gets deleted as part of that governance?
Yeah, so I mean, in the end, those are policy decisions, right? So, so at the Allen Institute for Immunology, we've decided not to delete data, right? We archive data, so it might be deleted for the average user, and so you might, but under the covers is still there. So we do a lot of soft delete. But other organizations might make the decision that they want to delete data. Some organizations think of it as of their best interest to actively delete data after a certain age for reasons like legal reasons. So whatever you do with it is up to you as a policy, but I think this approach allows you to enact whatever policy you want to enact. Samir.
Hi, Paul. A nice presentation. I had a question regarding generating these traces. Is there a cost to, are you able to measure the cost of running, for example, these traceability graphs? Because it would be interesting to say, look, if I generate this, it might cost you X thousands of dollars, but that is still a lot less than like 6 months of someone having to go back and regenerate this analysis or this experiment or like reinvesting in a study to regenerate the data. And that might be something interesting for us to get visibility on the back end.
I mean, it's a hard question because it really depends on how do you do analysis, right? So if you do an analysis sort of in a fairly sort of one-shot manner, then that's very different from if, and I say this on purpose, to say, no, it happened when you do the same analysis 20 times, and you end up with 20 traces. But I will also say in the end, archiving makes data a lot cheaper. So I think in the end, archiving is, it's not free, but it's pretty close. So telling people just, do your research, create your traces, don't worry about the ones that you don't end up using because we automatically get rid of it, and it really incurs very little cost, as opposed to not doing it or the opportunity cost of saying, oh, I forgot what I did or what exact code I used and end up maybe publishing the wrong results or not being able to reproduce it yourself when asked to and having to deal with all that sort of overhead and maybe embarrassment. To me the choice is clear which direction you should go. That's a great question.
Hi, Paul. I was wondering if you can, what's your vision on, particularly to highs, right? Because let's say we trace the data and somebody want to, in terms of open science, wants to replicate our analysis. And do you envision they as a user in highs or how because I can see that one way would be we release the data, for example, in Ultra, right? We release data, release the code, somebody will be able to replicate those versus they have to register in highs that relate to, I guess, a cost and affordability to the particular, I guess, outside institution. How do they use it? And do you use, what's your thinking there?
I mean, so in the data apps today, we have multiple avenues, right? You can actually download the data to your local machine and take the code and rerun it. And I think we also, so you can do that. You can also, we can set up automatically set up a small computing environment for you. I don't know if anybody played with that, but you can actually go to a certificate of reproducibility and ask to have a mini highs environment set up for you to really redo the steps in the certificate, and then you can run it as is. So I think there's multiple opportunities that you have there. In the longer run, we are definitely talking about making highs, make it much easier for individuals to sign up for highs and just use it as a computing platform and import their own data. And so if we go to that solution, then reproducing steps as others have done in highs becomes even easier. Anybody else? All right. Well, in that case, I'm going to keep on talking and introduce Andy. So Andy has been the Allen Institute for 2 years now, but he was at Vulcan before, so not exactly a new person. Andy runs the CTO organization, and I am happy to call him not just a co-worker, but also a friend, because I've really enjoyed the conversations we have about science and the role of technology in science, as well as the many intricacies of the Allen Institute. Without, further ado, Andy, go ahead. Thanks, Paul. Of course.
While you're clapping, we should clap one more time for Paul's presentation. It was really an excellent presentation of work. And I have to start by saying, ultimately, thank you so much for having me here, but I have two specific call-outs, two words of gratitude that I want to share with you all. One is, I've been here 2 years, and immunology has been by far the easiest, the most wonderful, the most technically sophisticated group to work with. And I don't say that I have favorites, but really every interaction I have to work with your team has really been a treat. And so thank you so much for all the hard work that you put in and really kind of welcoming me. The other thing is that, a more personal note, 15 years ago this week, I was diagnosed with metastatic melanoma. And I owe my life to immunotherapy. I was enrolled immediately in a vaccine trial over at Fred Hutch. And ultimately, whether it was successful or not, I'm still here. And 15 years on, and no evidence of disease. So I really benefit. I'm proof positive of the benefit of the work that you guys do on a daily basis. And so I would be remiss if I didn't say thank you as well. To know me, and so I don't have as beautiful slides or as calming slides as Paul did. Those transitions were a thing of beauty. I never figured out how to make animations work. But I want to basically do two things in the time that I've got with you today. One is talk to you a little bit about who I am and how I got here, and then transition and talk a little bit about what Octo does and how it can benefit you in terms of the work that you do. But I like kicking off things, not because I'm an egotistical person, but I like to talk about the things that matter most to me. I am father to two little chuckleheads, Mira and Allie. They're both going to have birthdays next month. Mira's going to be 14, if you can believe it, and Allie's going to be 10. I'm husband to Laura. We're both computational linguists by training. And so things that are important to me are, our Seattle sports teams, especially the Seahawks. Machine learning is something that's near and dear to my heart. As a native Philadelphian, I'm not just a big fan of the Phillies, but also of Tasty Cakes. And if you know, you know. And the easiest way to get me to kind of change policy around here is delivering Tasty Cakes under my door. It's 631 on the 6th floor. But my PhD was in computational linguistics, and Paul's, yours is too, right? Psycholinguistics. So we are, if you have anything to blame the field of linguistics for your technology infrastructure. My first 10 years out of graduate school was running a research company focused on really making AI real for for government customers, most specifically working with natural language processing. So my kids tease me on a regular basis, that I had the opportunity to work for, I worked 10 years in natural language processing, and I didn't invent ChatGPT, and they really want to know why. But after about 10 years, my wife gave me an ultimatum. She had moved to Seattle to work for Microsoft, and she said, I had to sell my company and get my butt up to Seattle or we would have words, and I didn't want to have words. So I took the first job that was offered to me. It was the CTO of a failing startup backed by Paul Allen. And I lasted exactly 6 weeks as the CTO of that startup before Paul came down one day and fired the entire executive team. And I was packing up my bags, and he came into my office, and he wasn't well at the time. And he said, "Where are you going?" And I said, "You just fired me. I'm leaving." And he said, "No, you don't get to leave." And I said, "What do you mean I don't get to leave?" He's like, "You make sense. So why don't you come up to the 11th floor of the 505 building in Vulcan and figure out what we can do together." And that began the most wonderful period of about 6 or 7 years where I developed a mentor and a friend and a close collaborator. And we did a bunch of fun things along the way. I kind of made sense of his VC portfolio, especially in AI. Really, again, to get back to a theme of trying to make AI real. We created a company from the ashes of Kiha called ARO, which ultimately sold to Samsung. Along the way, we founded the Allen Institute for Artificial Intelligence, our sister organization. And basically, I was the person in charge of the technology portion of his philanthropic portfolio. So doing things like building AI systems to kind of counter illegal fishing in the South China Sea, flying and crashing drones all over Botswana that essentially were supposed to look for elephant poachers, but really just could only spot elephants from this ground, or elephants from 300 meters up the sky, and really had a high propensity to hit trees, especially in a place where there weren't that many trees. Somewhere along the line, my wife gave me a second ultimatum and said, "Dude, you don't have to be saving the world." My kids knew that there was a ring that would ring, the phone would ring especially for Paul when he called 3 o'clock in the morning. And my daughter was 3 or 4 years old at the time, and she said, "That's Paul." And so I left his orbit with a promise to be back again someday. And he said, "No one ever comes back." And so I feel like this is being here today is kind of a promise fulfilled. But I went to Intel and built an enterprise AI software business for them before I lured back to Microsoft, where I led a big chunk of the AI platform at Microsoft, including the initial steps of the OpenAI relationship there, before being lured away by fame and fortune to be basically the head of AI for Accenture. Along there, I was living a happy life trying to figure out what consultants do when Rui called me out of the blue. We'd been connected by a mutual friend. And he didn't say hi, he didn't say hello. He said, "You have unfinished business." I said, "What do you mean, dude? I just met you." And he goes, "Paul needs you." And I said, "Newsflash, Paul's been dead for 5 years." And he basically proceeded to kind of lay out a vision that was too compelling for me to pass up. He basically said, the Allen Institute is a world-class data collection organization, and there's nobody who competes with us in terms of the quality of the science that we do and the data sets we can create. Ultimately, the field, though, is moving in terms of not just creating data, but making sense of that data. And for us to be able to do that, we need to create an AI culture and a machine learning culture and a data analytics culture that's really, truly embodied by the work that you guys do with HIGHS and the work that you do in Immunology All Up. But we really need to kind of invest in that, make sure that we can actually set ourselves up for success in the next 20 years, where creating data alone is not enough, but it's actually driving insight at scale and really kind of moving fast using AI. And I said, sign me up. I don't necessarily know what a consultant does anyway. And it's been 25 years since my last biochemistry class. What could go wrong? And so I've been here 2 years, and hopefully things haven't gone that wrong already. Octo, like Gall, consists of 3 parts. We have an engineering and infrastructure team that really augments the work that you guys do in your technology teams on a daily basis. And we're so fortunate to work with Paul and your team. We have an AI machine learning team that's led by Grace Wynn. If you haven't met Grace, you should make time. Grace is just an incredible person, but also an incredible AI machine learning leader. And she's got a team of about 6 or so right now, machine learning scientists who work closely with science units directly to be able to kind of build models. And so we're actually scoping projects now with Troy and Pete and Paul right now to try to figure out exactly what we can bring some of that AI goodness to AFI. But we're actually we're really keeping that team busy with actually building foundation models that we hope to move the needle. The third part is the most mysterious organization at the Allen Institute, which is Studio D3, which is yet to launch. We're really excited about actually making an offer on a director, and so we're really we haven't had a leader. You guys know what that's like, and so we're excited about bringing in a really excellent person in to be our leader. But D3 really is designed to kind of close the loop between data science and theory. And so the idea is, we believe that theoretical work in biology has a lot to say in terms of the direction. It can't just all be kind of bottom up from data. But ultimately, theories are best constrained when they actually have a tight operational loop with data science. And so we want theories to be able to derive from the data and insight that you can actually produce with a platform like HIGHS, and then ultimately used to be able to inform or design experiments that can be used in the wet lab to actually collect data to kind of further that development of that theory. And so we have about 25 folks who work in D3 today, largely coming over from the Mindscope program, but they try to embody that work especially in terms of neuroscience. And we're growing right over the next 18 months. You'll see us kind of add wings of that team for immunology and for cell science and synthetic biology, and really kind of coalesce in terms of vision under our new director. I could talk to you all day about the kinds of things that we do or things that are important to us, but I basically figured I'd lift a slide for my board of directors presentation next week and talk about the pillars. Let me say that this is not Octo's job alone. In fact, Octo doesn't do anything alone. Octo actually works closely with all of you, and we can't be successful if we're not working lockstep with you all. But our priorities are often, you'll see many of your priorities kind of reflected in our priorities. Our job is to really help you build the world's most productive biological data estate. Right? When Paul talks about making data, also making sure that data is useful and understand who's using that data and all the wonderful work that you do with your certs. We want to make sure that we're embodying that across all the petabytes of data that we have at the Institute. We want to make sure that we're operating not in silos, but engineering teams specifically. And I care more about engineers than scientists, unfortunately, because that's my remit. But ultimately, the same thing goes for scientists as well. But specifically, the goal that I have is to make sure our engineering teams across the Institute, whether you sit in C-Hub, whether you sit in AFI, or whether you sit in ABES, can actually collaborate and benefit from each other, and we can actually have resources that are elastic and shared across projects. I mean, all too often I get people to come to me and say, I would have been able to achieve all my goals for this year if I only had 6 more developers. And I go, well, why 6? Why not 8? Why not 10? And they say, well, 6 is what I had in the budget, but the budget got moved to some other category. And I think that that kind of thinking is outdated, and we need to be in a world where we're actually operating as a matrix engineering team, where we can move resources from silo to silo and ultimately go where the need is. I think we spend a lot of time thinking about cost and in terms of compute. My team is actually going to be underwriting all the GPU costs for the institute going forward. So we've been working with the HEIS team to actually enable GPU training and model training and deployment on GCP. And so basically HEIS will be the front end for basically anybody who wants to build a model or train a model or deploy a model on GCP, working closely with the BKP team to do that for AWS. But ultimately, we don't want cost to be a limiting factor for your foundation model ambitions. And so I have been graciously granted a significant budget to actually underwrite that cost. So your cloud costs are still yours, but if you need money for GPUs, please come to me and let me know, and we'll make sure that we help you kind of achieve those visions. I think we don't want to be constrained in terms of our training infrastructure. AI2 has a fabulous data center that they built out in Texas. We've now, through the work that Paul's team has done, and we can actually integrate and use cycles from that data center. But we also have ample opportunity to be able to actually use cloud-based GPUs as well. And so, we really don't want to be constrained by cost or infrastructure. We want to make sure that we have the resources to make sure that we're solving the problems that you find most strategically interesting. I think we're a small but mighty team at Octo AI that's led by Grace, but ultimately we're really underwriting a lot of work to be able to kind of hire and recruit best and brightest talent in terms of AI and machine learning for science, and not just in doing that in service of the goals that you have in terms of the science units themselves, but actually do that in service of scientific discovery all up. And so we have a number of collaborations that I can talk to you about in another time with folks who are building agents for scientific discovery, large models like RBio that we're building together with CZI, and ultimately foundational models that can be orchestrated using other kinds of agents. I will leave you with a challenge. I think this moment matters the most. Science, I don't have to tell you that science is moving faster. The volumes of data that we're dealing with are increasing. It's more complex. We're dealing with multimodal data or nothing these days. And AI use is accelerating, and we're going to a point where 2 years ago, I came in and people said, AI is going to solve all our problems. And now 2 years later, people go, well, AI is not going to solve all our problems. It can solve some of our problems. And so we need to figure out exactly how we keep up with the pace of progress. My wife used to tease me when I took this job. She's like, dude, I'm so excited for you. You don't have to just read archive anymore. And I said, yeah, I have to read archive and bioarchive every night to make sure that I'm keeping up with the pace of progress. We all know for a fact that budgets are tightening. The changes to the federal landscape means that we need to be more efficient and figure out exactly how to kind of be cognizant of how we spend money. I think the third thing that I would challenge you all to think about is how can you break down the silos? We're talking about, the institute model has served us well, but you can't study it's going to be increasingly the cross-disciplinary value of working together is increasingly apparent. Ultimately, does it really make sense to study the brain independent of the immune system? Or does it really make sense to study the immune system independent of other kind of systems of the body? Increasingly, the answer is no. And so we need to figure out exactly how we stamp out parallel efforts, work closely together, and make sure that we're driving impact the way we want. And so, really, I feel like this is our pivot point. This is the opportunity for us to really operate as one institute. So if you hear me and, my slide got cut off. So spelling issues notwithstanding, the challenge that I leave to you all is how do you think in your work, how do you kind of live the kind of truth of being one institute all up as you kind of go about your daily business? Thanks so much. Considering I'm all by myself, either that's time to throw things at me or ask questions or let me get off stage. Are you allowed to ask questions, Ernie?
Yeah.
Okay.
So, Andy, in terms of, can you talk a little bit about what your organization is doing in terms of
preparing and training really the whole institute and on the use of AI and machine learning?
Yeah, I mean, I think our flagship event that many of you participated in is Nautilus. We're going to run that Nautilus back next year in February. And so that is our effort to really kind of have a hackathon style kind of approach to teaching people what's possible with AI, understanding what the vendors are offering in terms of products, and really kind of get your hands dirty and kind of figure out exactly what's going on. I think we also have work streams where we're actually doing, building closer bridges with AI too. So we have a journal club that goes on once a month. In fact, where we bring a whole bunch of scientists from AI2 over here and actually fill up this room and talk about the work that we're doing together. And so it would really be great to bring your data scientists and your AI folks together as part of that. And the third thing we're really kind of leaning into is building relationships with other cloud providers and leading AI companies. So we're excited about the work that we're doing with OpenAI and Anthropic, the work that we're doing with NVIDIA, and ultimately you'll learn a lot more about those relationships, but those will translate not just in terms of resources that we can use in terms of compute, but also in terms of learning opportunities and training opportunities for everybody involved.
I have a question. I wonder your thoughts on the future of the AI is a generalizable, like a AGI type of model, or a specialized, say, biological data-driven AI model. And what do you think of the two?
Yeah, for years I've resisted the label of calling myself an AI person because I felt like AGI is a bridge too far. And so really what I feel like the path to anything approximating AGI is building a series of domain-specific models and then orchestrating them with kind of increasingly more intelligent agents. I mean, I'm excited especially by the work that CCI did with RBio recently, where they basically had multiple verifiers that says no one single model actually has to have the full proof positive answer. We can actually take probabilistic kind of confidence intervals from each different models and build basically a chain of reasoning that allows us to actually conclude something that approximates the truth.
Hi, Andy.
Hey.
Wonderful presentation.
Thanks,
I had
Matt.
a question regarding sort of the education and culture adoption, because there's been a lot of, on some ends, a lot of enthusiasm and then a lot of hesitation, and then there's this cycle of overhyping and deliverance and whatnot that hides some of the real impressive progress that's been being made. And I was wondering, what are your thoughts on that, and how can we sort of retain what is providing value and sort of sift through the noise that's going on with the sort of the AI landscape?
Yeah, I mean, I think what we have to do is be insistent that we're use case dependent in terms of the work that we're doing and understand the value that these models can create. I had a really well-respected person come to me not too long ago and said, I want to build a ChatGPT for all the biological data at the Allen Institute. And I said, good. How can I help? And he said, well, I'm assuming we just need to take all the data and dump it into a pile of GPUs and stir it up with a bunch of linear algebra, and at some point it's going to come out, it'll have a great model at the other side. And I said, yeah, but ultimately, how will you know what it does? And he said, I don't necessarily know. That's your job to figure it out. And so the kind of approach that we've been taking on a regular basis is kind of starting with data sets and starting with scientific questions and really building small models first, or small ambitious models that kind of do a few things well, and then really kind of try to bring them together. And making sure that we're always cognizant of the ROI, the return on investment that we're establishing, I think is the right way to go in terms of thinking about how we carve out an investment strategy. Sure.
My question is kind of...
Who are you again?
My name's Paul.
Hi, Paul.
I work here. My question is kind of similar, but sort of looking inward. Like, we have so much data, we have so many possible questions. Can you provide any sort of insight, what you've seen, the types of approaches that are useful versus the types of approaches that are maybe less useful? How do you match a data set to a scientific question, or because I think what I often see that people go, well, there's so much data, and I think AI can do sort of everything, or maybe not. I'm not quite sure. So, is there anything you could provide in terms of a sort of a starting point of these are the types of questions that might be interesting right now and doable right now? Maybe stay away from some other approaches that might be higher risk or maybe
Yeah.
not deliver you a result?
I think there's three things that I look for when I'm scoping a project. One is, do you have evaluation data? Do you have gold standard data that you can use to kind of evaluate the progress that you're making in terms of the model? I think the second thing is, do you have the aptitude to be able to have the human in the loop? Because ultimately right now, especially regardless of whether you're zero shot or better, having humans in the loop is an integral way to actually doing development. And the third thing is, do you actually have enough, do you have actually line of sight into all the data that you would need? And so, I mean, the question, I mean, I don't think there's any kind of measuring stick or ruler that can be used to say exactly how much data you need to build a model that does foo. But ultimately, the question is, you always need more data than you ultimately have. And so the question for us is, do you have a vector to be able to actually acquire the data that you need? And so if you can start with knowing if you're right or not, necessarily knowing where the data is going to come from, and actually having experts kind of tailor your progress, I mean, all the questions you ask themselves fall away to the wayside, and really can be kind of solved through hard work as opposed to some sort of oracle.
So with growing demand for GPUs and the increased resource shortages to make more to meet that demand, have you had any thoughts on how we can ensure that we can meet capacity for the Institute?
Yeah, I mean, it really starts and ends with our relationship with the cloud providers themselves. I think I have 10 emails a day back and forth with Google and Amazon about making sure we have different SKUs available. I think the exciting thing is that we were able to negotiate with Rui to be able to actually set aside several $1 million in terms of money that we can use to buy dedicated instances. So we won't have to worry about provisioning instances in an ad hoc fashion. We'll actually be able to buy them and have some serious core capacity that we can use permanently across the Institute.
Any other questions or any questions online? Elizabeth and Michelle, anything come through online at all or no? Okay. Nope. Nope. All right. Well, please join me one more time in thanking Andy.
Thank you, everybody.
Thanks very much, Andy. Okay, I think we are going to switch formats because Catherine is going to be joining us online to help us answer some questions that came in about accommodations and promotions. However, to do that, we need to switch to using Teams. So
Yeah, so anyone that's listening right now on the YouTube stream, you can jump off that and then open the Teams meeting for the Q&A that starts at 1, and we're just about to jump on that call, and you should be able to hear our questions in the room.
Yeah, thanks, Andy. And so, and then, so while Stephen does that, so we're kind of going to transition into the senior leader office hours that we normally hold. It just happened to coincide to be right adjacent to each other. And we'll start with the questions that came in that we would address during